Hi everyone, Krishna this side. So in this video, I'll be covering this candy problem from LeetCode. Problem number is 135. Let us go through the problem statement first, then I'll explain the logic and we can write down the solution as well. So let's go through the problem statement first. There are real young children standing in a line. Each child is assigned a rating value given in an integer array rating. So okay, we have given an array of integers which has the ratings for those children. You are given candies to those children subjected to the following requirements. Each child must have at least one candy. Children with higher rating get more candies than their neighbors. So we need to return minimum number of candies. You need to have to distribute to the distribute the candies to the children. So we need to return the minimum candies that is required to distribute the children, considering these both the conditions. So what are those conditions? Each child must have at least one candy. Okay, and children with higher rating, uh, who is actually to the neighbors, should get more candies. Okay, yeah, so it is problem is straightforward. So let us discuss with an example, and I'll tell you like this is like a similar problem type which is available. If you guys look into the trapping brain water problem, there also we can apply this same logic and we can solve that problem also. Okay, so let us take an example. If we have this rating, this like let me build an array. Um, Okay, this is the array which has children's rating, and initially what they said is like each child must get at least one candy. Okay, so what we can do is we can create another array where we can fill the array with initially one for each of them. So we will distribute one candies to each of them. Now any child whose neighbor is having higher rating should get more children who is higher rating than its neighbor. So either side, okay, if it is in the left side, if the child is having lower rating than him, he should get, doesn't matter if in the right side if it is having less or more. Okay, so any of the side if it is having less rating should get more candies. Okay, so what we can do is we will start from the left side. We will check if any time if the rating is higher. If at any point in time if we see a higher rating, we will simply update the candies. Okay, so initially if it is having one candy, so whatever the neighbors has candies so far, we will increment it with one. Okay, so from the left side, left to right, first we will go and we check if at any point in time if rating is higher, we simply add on candies whatever the child neighbor child is having, those candies we consider plus one candy we will add it so that he will get more candies. Okay, and same thing we will do it from the right to left side. So from here to here again we will check simply if at any point in time if the neighbor is having less candies, then we will simply add the candies. But at this time what we will do is we will simply compare it with the previous candies array that we formed from the left to right. Okay, if that formation has more candies, so simply we consider that higher one. So what I'm trying to say is let us first build from go from left to right. So first initially for the this leftmost child, he will be having one candy. It doesn't matter because we are not having any like childs from this side, right? So for this particular one, now it is having higher rating than this one, right? So what we will do is we simply whatever the candies the neighbor has, we will get that and we simply add one. So we will do here 2. Now here it is 0. So obviously it is not this rating is not more than this previous neighbor child. So we simply whatever the value initially we have kept, that is something what we will keep as it is. Okay, now 1 is there. So this rating is more than this 0, right? So obviously we will get one candy extra because whatever the candy that we have, we will add one to it. So 2 has been here now. Now 2 is again more than 1. So again whatever this value we have in the neighbor side, we should add one more candies to that. So now this will be 3. Now here it is 1. So this is not more than this one. So whatever the default value that we have, we will keep as it is. This 3 is there. Now with this 3, obviously this rating is higher than this one. So what we will do is whatever the value we have in the neighbor side, we will just add one to it. So 2 is what we have now. 5 is obviously higher than this 3. So whatever this 2 rating we have, right? Because obviously if 5 is there, so neighbor's rating this rating is more than this one, right? So obviously whatever the value we have, we need to get more candies than previous one, right? So whatever the neighbors has the candies, we will add one candy to it. Okay. So 3 is what we have now, and then 2 we have something right over here. So what we will do is with the 2, obviously it is less rating than this 5, so we will keep the whatever the default rating we have, that is something what we will keep here. Now 1 is not higher rating than this 2, so obviously whatever the default rating we have, we need to keep at this. So this is like from left to right we check, but there is a possibility that from right to left also any this two's neighbors are 1 and 5. Obviously one this neighbor is less rating than this two, right? So this value, if at any point in time if it is less, we need to increment it, right? So at any point in time, whatever the current children we are at, the neighbors is something what we need to look at and check. If it is having high less rating, then we need to increment the value, right? So what we will do is from right to left again we will go, but now we will compare with these previous values as well. Okay, if the previous value at any point in time is more, then we will keep that value, or else we update the previous value. So with the same array, what we will do is we will go from right to left, from this right to left, and we keep this array in mind, and at any point in time if we have maximum value obviously in the previous array, so if that is the case, we will keep it as it is. So for the one, by default whatever the value this we have updated array, that is going to be the same. Now for here this 2 is having higher rating than this one, right? So obviously we compare with this one. So currently it is 1, and this new, from this new array what it happens is like this 1 plus 1 we will be having 2. So 2 is obviously greater than 1, right? So we will update this value with the 2. The same array we can update, or else we can create another array as well, but it is better to update with the same array. Now here it is 5. Obviously 5 is more than this 2, right? But now the updated value will be 3, and previous value is also 3. So anyway whatever the value that we have, we can keep it as it is. Okay. Now next is like 3. 3 is not higher than 5, and it will be having 1, because this comparing with this neighbor, it is obviously less, right? So it is going to be 1, but previous time it was updated to 2, because from this left to right it was having higher precedence, right? Because it is having more rating. So we compare with this and new updated value, and we keep the maximum value what we have. Okay, 2 is what we will keep here. Now here it is 1, so either of those side we didn't get any higher less rating side, so whatever the default value we will keep at it as it is, that is going to be 1. Now next is 2. Obviously 2 is more than 1 comparing with the rating. So by default it is having 3, and the updated value is going to be 2, because we just get this value and we add it to 1. But this 3 was more than this 2, right? So obviously it is going to be 3. Now what is this 1 again, right? So for here it is 1. So by default it is going to be 1, because comparing with 2, this value is less, so obviously the rating will be downgraded. So here it is 1, but from this left to right, it was having 2 value, right? Because the neighbor is actually having less rating comparing from the left side as to right side. So whatever the highest value we get, that is something what we need to keep right over here. Now next is 0, so obviously it is going to be 1, and 2 actually it is more than this 0 rating, so it is going to be this value plus 1, or else whatever the maximum we have already, so it is going to be 2. And for 1, obviously 1 is actually less, so than this 2, so it is again going to be 1 by default. So this is the updated latest arrays by distributing all of them. So we just need to add all of them to get the minimum candies that we distributed so far. So that is how this logic is going to be work. And let me write down the code, and then also I'll explain you like how these things are working. So what I'll do is I'll create a candies array with let me get here the size of this array. Okay, and here I'll put this candies array as n, and let's go through this from left to right. I wanted to go. So for first one, by default it is going to be obviously 1, or even for the right side it is going to be 1, because by default those values are going to be, because there is nothing from the left side, right, we as to compare, so it is going to be 1. So we will start from the first index, and what I'll do is I'll fill it this candies array with by default initially with 1. Okay. I filled this array with 1, and then we will start and go till last index, and we simply just need to check if ratings ratings of I, if this I mean the second index rating, if it is greater than ratings of previous index I minus 1. If that is the case, we simply update the candies of I to candies of I minus 1 plus 1. Okay. Yeah, that is the case. If not, by default, whatever the one value we kept, that is going to be there for all of the other cases. Okay. Now, simply we just go from right to left, and I equals to n minus 2, because last index is obviously we are not considering here now. I greater than equals to 0, I minus minus, and if ratings of I is greater than ratings of I plus 1. Okay, this is the case, right? From right to left. So we simply update this candies of I equals. Now here I'll simply perform the max operation with candies of I, the default value, because from the right to left, if at any point in time if max value is there, then obviously whatever the latest updated value, we don't want to consider it, right? Because if that is giving us minimum value, then it is going to be wrong, right? So yes, what I'll do is candies of I plus 1 plus 1. Okay, either of them, whatever the maximum value we have, so we simply update it into candies array. Now let's create some variable here for uh, int I equals 0, I less than n, I plus plus. Here we simply add the max candies of I. Okay, we add them and we return simply the sum, because we need to return the minimum number of candies, right? So that's the sum that we need to return. Let me run it. There is an error, line number 16. Okay, so yes, if we consider the time complexity, it is 2 times n we are running it, so 2n is actually n, and then sorry, n plus 1, that is 2n, right? And this is the n size array that we are using, so space complexity is also going to be n. So that's all from this video. I hope you guys got some learning. So you guys can try out the trapping rainwater problem as well. It is actually similar. We just go from left to right, and then again comes back, and we compare those values. So that is like it is fall into the similar categories. So you can try it out. So yeah, that's all from this video.